All right, no. We didn't set up a part of it. All right. All right, so that's just actually streaming. All right, let's get this out of the way. Actually, on the wrong screen. I'm going to change this here. All right, so you can record meanwhile. All right. Oh, wrong button. All right, so we're going to go back to the experiment now. All right, should be good here. All right, so everybody should be seeing this. No. All right, so these are the distances that we're going to adjust, guys. We can make it small, we can make it large. This is the widest it can be. All right, here's the car. What's that in here? All right. This is so all right. So this is the trolley here that we're going to let slide down, and the distances are given. I think this have all right. There's a bug in there. All right, and it's actually telling you what to do here, but let's come out of that. Not allow me to interact. Let me change the angle. See if we can get a better view. All right, there we go. All right, now we set the angle at 20. This is we're at 20.6, but can adjust that. All right. And so this is the time now to allow this thing to start to move. We press this button here. Now, what it's gonna do now is gonna give us 2 times, guys. Again, the T1 and T2. Everybody can see that?
Yes, sir.
Sir.
All right, let's just get back on the image here. I want to put it at an angle where you can see everything happening. All right, so around there, still have that you want this to black the screen. All right, so now originally, all right, let's say increase the distance still. So maybe we can use like 5 or 6 different distances. So let's use like, well, we can start from like a 30 or maybe a 20 centimeters. Would be some from 45. If we start here, that's 30, 33. And if that's 20, so that will give you what, 53. And they're about 53.3. Certainly. Actually 53.1 is where we can get it. So again, they're seeing some limitations here in this experiment. You can't really adjust it virtually so easily. All right. But this experiment will have some source of errors that you're going to need to find out. Like for example, let's see here what happens. Or can you predict what errors could happen in this experiment? That's a better question now. Anybody can predict what might happen here? No. Come on, man.
Sir, maybe not join to scale.
No, you can't see that. Trying to scale. What do you
Something
mean?
like that, sir. Like
Sir,
when I do it, sir, I go on camera.
Mm,
sir, we're not gonna get an accurate reading.
mm. All right. source of error. At cape level, those are not the things you want to tell them. All right. The source of error, right, could be errors in timing. You have to be more specific. If you're talking about an error at cape level, you have to tell me what error specifically you're talking about. You understand that? So it means that if you're going to say, if you're going to talk about the well, all right, in terms of the timing, you're going to have to talk about possible errors in measuring time due to use of stopwatch or reaction time. Those are things that you need to be aware of. Reaction time, or you could say the accuracy or the sensitivity. Right? Reaction time, sensitivity of device. Better get that?
Yes, sir.
Yes, sir.
All right, sensitivity of photo gate. So not all photo gates are the same. No, you have cheap one, you have dear one, and as well. So all of that. And as a matter of fact, I'm gonna add one. Since this is a virtual lab, I'm gonna write it on the lab sheet so you can see them. Right. But so far, what I have written down is the reaction time, the sensitivity of the photo gate, and the algorithmic so it's the algorithmic errors with the virtual lab. So all right. No, I won't go into what that is because I might hit my authority, so that way discuss that. But those are three errors. All right. So anyway, so this is 20. So all right, this is 20 centimeters here. And so it's gonna pass at 33 and at 53. Right. So in the table, you'll write that distance down as 20.1. But it's gonna be in meters, by the way. So remember, from centimeters to meters, you should know how to convert that. All right. How convert from centimeters to meters?
Or divided by 1,000.
Actually, divide by 100. So therefore, it's gonna be 20.1
Yeah.
divided by 100, and this would give you 0.21. All right. So that is the distance that you will have in your results, and then we're gonna get the time. All right. So now to get the time, now we're gonna release this. So when click that, all right. Notice that it slides down, and then 2 times are recorded here. All right. So the T1 is going to be 1.3. In fact, well, let's round it off to 2 decimal places. Or, well, yeah, or probably 1. Let's do it for 1 then. If it's going to be that, it's going to be approximately 1.4. Well, I'm going to use 1 decimal place. Why? Because we have 1 decimal place for this already. So let's keep it consistent. If it's 1.386, how could we write that to 1 decimal place?
1.4.
Okay, good.
1.4.
All right, let's just go with 1.4. Again, now, if you're doing that now, you're going to have another source of error. All right, now, you're going to write that values of time were rounded off to 1 decimal place. To 1 dp. Now, we could deal with this 2 ways. We could keep it. We could keep the 3 decimal place until we work out the average time, or after work out the time. So because what we're going to end up doing here is going to subtract. We're going to subtract T1 from T2. to get the time that it took to pass from here to here. But do you understand that?
Yes.
Yeah. So the car would have would have passed these 2 points, and then it took the time for this one and for the second one at 53.1. So what we could do here, let's keep the 3 decimal place in, and then when we work out the difference now, we put that to 1 decimal place. But there's certainly in the source of error, we're going to write down that we rounded off the time to 1 decimal place. All right. So, and why I want to do that is that because we know when plot the graph, we want to also make that easy as well. All right. So let's all right. So let's put 1.386 for now, and then we change it afterwards. All right, because for K-plabs, so errors are it's something else that them look at as well. Work out error, but we'll do that afterwards. All right, so T1 is 1.386, T2 is 1.727, and then now we're going to subtract that. What time you get when you subtract that? All right, work out that now. Tell me the answer you get. All right.
Sir, me get 0.341.
All right, 0.341. All right, so write that down in the table. All right. Actually, the angle here is 20.5. This is 20.6. So yeah, all right. So we're gonna go to the second one. All right. So we're going to do here. We're going to adjust the distance once more. And let me see. It's a restart here. All right. And it's not allowing me to adjust this distance here. What's happening here? It should allow me to restart.